try this. So, how did that go? Okay, using the rational roots theorem, rational zero theorem, in the form of P and a Q, okay, the P and the Q, where the P was all the factors of the constant. In this case, our life is easy, plus or minus 1 or 2. And the Q's, yeah, just as easy, 1 and 3. Okay, so we're going to test some things out. For example, let's choose 1. Let's start with 1. Test it out. And using all the coefficients, we got 3, 11, 11, 1, negative 2. Use a synthetic division and use the 1 as a divisor. So bring down the 3, 3, combine, 14, 14, 25, uh-oh, this isn't going anywhere. 1 times 25 is 25, 26, 26 here, 24. That's not a 0, is it? Okay, our factor theorem did not prevail here. So 1 is not a factor. But don't give up. Let's try the negative 1. Remember, it could be both positive or negative. And see how many times that goes into the coefficients 3, 11, 11, 1, and negative 2. Bring down the 3, negative 3, combine 8, negative 8, combine 3, negative 3, combine negative 2, negative and negative is positive. Oh, hello, 0, there it is. Okay, so the factor theorem says if we take that k of the root x minus k back into the function, you should get a remainder of 0. And if it does, that is the k, that is the factor. So that's a good one. So let's try the next one. How about, let's jump. How about a negative 2? So let's do that over here, negative 2. Take that new polynomial now. Okay? Now it's been reduced by a degree of 1. So it's not 4, now it's 3. So 3x cubed plus 8x squared plus 3x minus the 2. Bring it down. Negative 6, 2. Negative 4, negative 1. And check this out. Again, I hit the jackpot. So that is also a factor. That is another 0, I mean. Well, what do I mean by factor? That negative 1 is the k. So in fact, it's written as x plus 1 is a factor. And x plus 2 is a factor. Are there any others? Well, let's find out. But wait. Now this one, I don't want to keep using the synthetic division. This actually represents the degree of 2 now. 3x squared plus 2x minus 1. And I think I could factor this using the AC factor. Remember how to do that? What are all the factors that become 3? Well, 1 and 3. How about 1? 1 and 1. Is there a way we can multiply them? So when you add the product, it becomes a positive 2 in the middle? Yeah, the 3 has to be plus, 1 has to be minus. So 3 multiplies plus 1, 1 times negative 1 gives you negative 1. So when you factor them, we'll put them in factor form, 1x, 3x, 1 multiplies negative 1, so negative 1 has to be over here. That means plus 1 over there. There you have it. So there's the other 2 factors. There's the other 2 factors. There's your 4 factors, 4 zeros. And what are the zeros? It's going to be x. Hey, there's 2 of them. So that's a square, I guess, huh? So x plus 1. Let's just put them together. X plus 1, 3x minus 1, x plus 2. So if you use a zero product property, the rational zeros are negative 1, 1 over 3, and negative 2. There you go.